Alright, so here is section 7.3, and our essential question is what are the patterns in the special products a plus b times a minus b, a plus b squared, and a minus b squared. So you'll see that we see some patterns that happen over and over again, and that leads us to kind of simplify things. We don't have to do all the long work. We can just kind of go with what we know. So our learning targets is, our first one is to use the square of a binomial pattern. Then our second learning target is use the sum and difference pattern. And then thirdly, we're going to use special product patterns to solve real life problems. So we're going to take those patterns that we learn and apply them. So here's my core concept, the square of a binomial, right? So if I have something like a plus b squared, that quantity, I cannot just distribute this 2 into both things and becomes a squared plus b squared. That's not mathematically accurate. So, but I do see a pattern. So I can take this when I'm adding my sum, right? And I have my a squared plus 2 times these ab plus b squared. And here's why it works. So if I have, for example, x plus 4 quantity squared. So this really means that I have x plus 4 times x plus 4, right? Because I take the whole thing and I square it. So now I can write this out, and I like to go horizontally, it doesn't matter, right? So I would have x times x plus 4 plus 4 times x plus 4. So here's where I get the pieces. So right here you can see I'm going to end up with x squared. So that first term, right, is going to be squared. Well, here I see I have an x times 4, and here I also have an x times 4. So I have 2 of those that I multiply together, right? So here I'd multiply x times 4 and multiply it by 2. So that's where those 2 come from. And then here I end up with 4 times 4, and that's that 4 squared. So this b squared comes from right here. This 2ab is because I have an x times 4 here and a 4 times x here, always. And then my a squared term comes from down here, right? So this is one of those patterns that I can follow, and it's always going to work. So the only difference you'll notice here is when I'm subtracting these two, I end up subtracting this middle term, this 2ab. My b squared is still going to be positive because when I have a negative times a negative, I end up with a positive. So this right here is the only real difference that you'll see in these. So just keep that in mind. So one thing we also want to note is that these work backwards, right? I don't just always start here and work this way. I can always see what I have over here when I have my trinomial and rewrite it in a simpler way. Now this will come in handy in the next couple of chapters when we start factoring and trying to simplify things. So we're just going to kind of keep that in mind for now, that this does work both directions. Okay, so let's find each product. So first of all, this 3x plus 4 squared is the same thing as 3x plus 4 times 3x plus 4. Now let's just double check that our pattern actually works, right? So I take my 3x times my entire thing, my entire second one, plus 4 times the entire second one. Now let's multiply it out. 3x times 3x is 9x squared. 3x times 4 is 12x. 4 times 3x is 12x, and 4 times 4 is 16. So now I see I have two terms with an x that I can simplify. So I have 9x squared plus 24x plus 16. So now instead of writing all of this out, I could have used my property that I just learned back here, my square of a binomial, right? And I know that when I'm squaring something, I take my first term, which is my 3x. So I'm going to take that, and I have that squared, and I add to it 2 times, and I multiply my terms together, and then I have my last term squared. Okay, so here's how I can just simplify it. I know that 3x squared is 9x squared. I know that 2 times 3x times 4, 4 times 3 is 12 times 2 is 24x, and I know that 4 squared is 16. So you see I get the same answer when I do it both ways, but this way just saves some time. So now let's look at part B, right? And so I see I'm subtracting here, so I know that my final answer is going to end up with a squared minus 2ab plus b squared, right? Because I'm subtracting, this middle term has to be subtracted. So I know that my a squared is going to be 5x, so I take my 5x and I square it. Subtract 2 times a, which was 5x, times my b, which was 2y, plus b squared, my b was 2y, so I square that term. So 5 times 5 is 25x squared. 2 times 5 is 10, times 2 is 20, so minus 20xy. 2 times 2 is 4, and y squared. Okay, so I can do this even if there's multiple variables involved and not just numbers. Just look at each thing individually, and then I can combine what I have and what I know. And so here would be my final answer. So if I was to write it out, I would still get this same answer. Okay, so here are a couple of problems that I want you to try. This is your monitoring progress. So see if you can do these using our pattern and not having to write everything out for the whole thing. Okay, so here's our other pattern that we're dealing with, the sum and difference pattern, right? This is going to be our second learning target. So here I see I have a term A, a thing A plus B times that A minus B. So here's what I'm going to always end up with. I'm going to always end up with this A squared minus B squared. Okay, so let's look at this in action. So if I have something like x plus 2, right, and then I would have x minus 2. So I see that my first terms are the same and my second terms are the same, but one's a plus and one's a minus. So let's multiply this out and see why it works. So I know I would have x times x minus 2 plus 2 times x minus 2, right? X times x is x squared. X times a negative 2 is minus 2x. 2 times x is a positive 2x. And 2 times a negative 2 is a negative 4. Okay, so now I see that I've got this x squared. I have a negative 2x and a positive 2x, and those two end up canceling each other out. And I have 4 here at the end. Well, and I know that the square root of x squared is x, which is this first term, and I know that the square root of 4 is 2, which is the second term, so it does end up working. And you'll see that example over here. This is just why it works out. So the other thing to note, right, like we said with the last core concept, is this does also work backwards. So if I'm given something like 9x squared minus 4, I can think to myself, oh, I know what the square root of 9 is, I know what the square root of x squared is, and I know what the square root of 4 is. And I can work backwards using the same pattern. So I know that my first part would be 3x, because 3x would be the square root of this entire first term, plus 2, and then I'd have 3x minus 2. We'll get to more of this later. If this doesn't make a lot of sense right now, that's fine. Just know that it can go backwards and forwards. Okay, so we're going to find each product here. So I see that my first terms in both binomials are the same and my second terms are the same. One's a plus, one's a minus. So I know that I'm going to end up with a squared minus b squared. Well, so my a term was t, so I'm going to have t squared minus. My b term was 5. And so then I can go ahead and do this math, so I'm going to end up with t squared minus 25. So now let's look at this example. So my a was going to be 3x squared minus, and my b was y squared. So I know that 3x squared is the same thing as 3x times 3x, which gives me 9x squared minus y squared. Do you see how much easier this is when I can recognize those patterns rather than having to write the whole thing out? I could write the whole thing out, but it just saves some time to do it this way. Okay. So we're going to use that same pattern to just look at some numbers so we can simplify things. So I see here that both 26 and 34 are close to 30, so I can rewrite those, right? I know that 26 is 30 minus 4, and I'm multiplying it times 30 plus 4. Okay, so see here again, my first terms are the same and my last terms are the same. So I know I'm going to have my a value, which is 30 squared, minus my b value, which is 4 squared. So if I go and multiply this out, I know that 30 squared is 900, and I know that 4 squared is 16, so I end up with 884. So this is a much faster way to go ahead and multiply these two things, these two numbers, rather than actually writing them out and multiplying. And it's using our same pattern that we've been using with different terms in our binomial, which is pretty cool. So here's some more monitoring progress. Go ahead and try these and see how it works, see what you can come up with. Okay, so now here's our word problem, right? This was our last learning target that we're going to deal with. So a combination of two genes determines the color of the dark patches of a border collie's coat. An offspring inherits one patch color gene from each parent. Each parent has 2 color genes, and the offspring has an equal chance of inheriting either one. So the gene capital B is for black patches and the gene R is for red patches. Any gene combination with a capital B results in black patches, right? And if you're in biology, you'll see this a bunch. Suppose that each parent has the same gene combination, has a big B and a little r. So here's my Punnett square. This is called a Punnett square. Shows the possible gene combinations of the offspring and the resulting patch colors. Okay, so first question I'm asked is what percent of the possible gene combinations result in black patches? So I first want to see that they've already colored these in for me, and these 3 have black patches and only 1 has red, so I know that my percent would be 3 out of 4 of those, which turns into 0.75, which is the same thing as 75%. Right? So I see that 75% would end up with the black patches. So now I'm supposed to show how you could use a polynomial to model the possible gene combinations. So one thing I can do is use different values and use these letters to help me get. So I'm going to look at this here. We're just going to click through this. Right? So this is part A that we already talked about. So I'm going to model each gene from the parent with 0.5b plus 0.5r. And I know that because each parent has one of each. So half of what the parent gives is a capital B and half of what the parent gives is that r. So there's an equal chance from each point. So that's why they're both 0.5. Okay, so I know that this is 0.5b plus 0.5r squared. And I know that because it's a square, right? So in the same thing on both sides. And so it's looking at the area is what we're really looking at. And I know to find the area, I multiply length times width or base times height, either way you want to say it. And since they're both the same, I can just use the squared to denote that. Okay, so I want to expand. So using my properties, right, I can see that I have a binomial that's squared. So I know I'm going to take the first term and square it. For the middle term, I take 2 and multiply these together times 2. And then for my third term, I take the last part and square it. So from here, I'm just going to go ahead and simplify, right? Because 0.5 squared is 0.25. 2 times 0.5 times 0.5 is 0.5. And then 0.5 squared is 0.25. So this tells me some information about what's happening above. We're looking at the coefficients. Now remember, here's one of our terms that we need to know is coefficient. A coefficient is the number that's with the variable. So we're just looking here at the numbers. So this tells me that 25%, right, that was 0.25. To turn it to percent, I move the decimal 2 places, but 25% of the children of these 2 dogs will have this genetic makeup, so B, capital B, and will have black patches. 50% will have black patches but have a capital B and a little r, and then 25% will have both of the little r's, so they will have red patches. So the numbers, the coefficients, can tell me quite a bit. So I also see here, right, because both of these terms have a B in them and deal with black patches on these dogs, that 75% result in black patches. And so that actually agrees with what we found up here in part A. So here we can just use some multiplying to use some real world examples. Okay, so here's your final monitoring progress, and this is pretty similar to the one we just did. So go ahead and try this and see if it makes sense when you're doing it by yourself. So let's review our learning targets. Our first one is use the square of a binomial pattern. And we used the square was either we had a plus in the middle and we also had a minus in the middle, so we can have 2 different pieces there. Don't forget that. Our second learning target was use the sum and difference pattern. So go back and look at that. And then our third learning target was to use these patterns to solve real life problems. The biggest thing is recognizing the pieces that you can use a pattern on versus where you have to multiply everything out. So now that we've done this, I want you to go ahead and start working on your homework for 7.3.